Welcome to an all you need to know video about the element potassium. Potassium is in group 1 on the periodic table and is an alkali metal. All alkali metals are silvery gray in color. They're soft metals, which means they can be easily cut with a knife, and they're all violently reactive with H2O and oxygen. On the periodic table, potassium has a symbol K, atomic mass of 39, and 19 protons and 19 electrons in a neutral atom. To find the number of neutrons in a neutral atom, you take the atomic mass and subtract the number of protons from that. So you have 20 neutrons in a neutral atom of potassium. Neutrons have no charge, protons have a positive charge, and electrons have a negative charge. Electrons can be found around in the orbitals around the nucleus in the atom, and in the nucleus of the atom are where the neutrons and protons are. Potassium has an electron configuration that of argons plus its 4s1 electron. That 4s1 electron is potassium's valence electron. Just like all other alkali metals, they have one valence electron. That one valence electron is the only electron potassium needs to get rid of for it to have an electron configuration like a noble gas. And potassium is very reactive because it wants to get rid of that one electron. And once it does get rid of that one electron, it becomes a potassium plus 1, which is a cation. Then it matches up with an anion to make an ionic salt. So nitrate is an anion, and it makes potassium nitrate. Potassium nitrate is a salt, and it's always soluble because of potassium. Any salt with potassium in it is soluble. Potassium nitrate can help determine the VSEPA of potassium. So the VSEPA is based on the structure of nitrate, which are all bonds they're all covalent bonds because of nonmetals and nonmetals bond together. And nitrate has a trigonal planar structure. Potassium has an oxidation state of +1 or -1. And we're going to use this example problem of two potassium solids being mixed with two water molecules to make potassium hydroxide and hydrogen gas. So potassium at first has an oxidation state of 0 because it's a solid. Then it goes to a +1 to make an ion. So then after that it oxidizes. So 0 to a plus, that's oxidation. Hydrogen goes from an ion, a plus, to gas, which is a neutral state. So that reduces. It is the oxidizing agent for potassium, since potassium oxidizes and it reduces. And potassium is a reducing agent since it oxidizes and it helps hydrogen reduce. The polarity of a bond between potassium and another element in a molecule can be found by using the electronegativity of potassium, which is 0.82. So we're going to do potassium iodide. Iodine has electronegativity of 2.66. So 2.66 minus 0.82 is 1.84. 1.84 is on the scale of 0.4 to 1.8, but it's not because it's bigger than that. So since it's bigger than a covalent or a polar covalent, it's an ionic polar bond. Anything less than 0.4 is a nonpolar covalent. So we already know that it's a ionic polar bond because potassium, being a metal, is bonded with a nonmetal, iodine. And we know that it's ionic because the electronegativities between the metal and the nonmetal are so great that it's polar. Here's some fun facts about potassium. Potassium makes up 2% of the earth, and if you were to buy potassium today, it's $40 per pound, which is crazy expensive. Potassium, I have a question about potassium. Try to use the knowledge you got in this video to determine what kind of bond there is between potassium and oxygen and the structure potassium hydroxide. So use your knowledge of electronegativity and the spectrum of bonds, or use your knowledge between metals and nonmetals to determine what kind of specific bond there is. Thank you for watching. That's all I have for this video.